Hey everyone, how are you doing? I hope you're doing absolutely amazing. Is that sound working? Yes, it is. I've turned the computer around so you have a little bit better scenery than the spare bedroom. That's my backyard. As you see, it's raining. We get 10 months of Antarctic Ocean and 2 months of outback here in Melbourne. So it's getting cold again, even though it's kind of still summery. So, black holes. Okay, black holes. What are black holes? In this video we're suggesting black holes are probably likely to be a ball of silver, copper, gold, aluminum, which is in turn coated with carbon nanotubes. And I'm also speculating that black holes were instrumental to the foundation of life on planet Earth. Because they would also have rare substances such as zinc, nickel, lithium. Where am I getting all these from? From a table of resistivity and conductivity. These are the most conductive elements in the universe, even more conductive than iron. Silver is 6.3 times more conductive than iron is. Copper is 5.96 more conductive than iron is. Gold is 4.1 times more conductive than iron is. Aluminum is 3.5 times more conductive than iron is. Then the tungstens, the zincs, the nickels, the lithiums. Do you recognize these elements? These are elements we take in supplements. These are instrumental for life. It's absolutely amazing. As you go down the conductivity table, you go through iron, tin. Carbon steel is not hardly conductive at all compared to some of these. It's only fractionally conductive. Lead is less conductive, and it goes down, 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 down. So, why does it need to be conductive? Why do black holes need to be conductive? If we look at the electric universe theory of what's going on, if we look at the conventional theory, what's happening is that we have, they say stars, black holes can be companions to stars, and they can eat stars. There's no picture of this. There's no photo of this. I think what's actually happening is the star is an accretion disk around a proto-galaxy, and it's all bunched up into a star. If you look at pictures of black holes, they're characterized simply by jets at the center of galaxies. So they show you a picture of a black hole, they show you the jets coming out each side. The electric universe theorists say this is a twist of plasma. The plasma is twisting through something that's rapidly spinning, and it's being focused. And a black hole is a focal point. The narrow point of the plasma at the galaxy allows, which is passing longitudinally north-south through the galaxy if the galaxy is flat, allows for an accretion disk because you've narrowed out the plasma in the middle, and the plasma gets wider on each side, so it allows an accretion disk to form in the middle. That's the electric interpretation. And things need to be conductive if they're passing through. So in the case of a black hole that's eating a star, I think what's really happening is the Birkeland current is going through the black hole because the black hole is highly conductive, much more than the iron in the star. Stars are iron, hydrogen, and other heavier elements. But I think black holes are specifically the silver, the copper, the gold, because they need to be more conductive than that star for the Birkeland current to pass through. Now, we go to the chemical definition. I have a chemical background, chemistry background. I think the materials engineers, the product engineers, the chemical engineers will have a better chance of describing black holes if they attempt it. I don't think they have, than the cosmologists. Maybe even to a certain extent the electric universe people. The cosmologists are a lost cause. They are doing everything on the blackboard. I would describe it as a mathematical form of prayer. Cosmology. If I went to a chemistry lab and I started doing mathematical equations and coming up with imaginary matter, they would throw me out. I don't have the physics or the maths background, but I can contribute a chemistry understanding to what a black hole is just by looking at materials science. And what right do the cosmologists have to ignore materials science, to talk about materials, invent exotic new materials, and be completely ignorant of basic materials science? So I'm going to read you an article that I wrote last night, and I'm just going to. So if I was a chemist, how would I make a black hole in a laboratory? So let's get to it. So I would look at the most abundant materials on Earth and in the Sun in order to examine what a black hole is likely to be made of. So abundant materials on Earth and Sun are the elements I've actually described, as well as carbon and iron. Iron is exceptionally abundant by weight in stars, it seems. The mass of a black hole, I think, will most likely be provided by heavier elements, possibly types of iron, but in particular conductive elements for the reasons we've just described below. If we look at the colour of a black hole, we see that it is indeed black. Partly this is because in electric universe theory, the black hole is being used as a conduit, not as a filament. The star next to it is being used as a filament. The galaxy surrounding a black hole in the middle is being used as a filament, while the black hole is a conduit, a cable as it were, and the energy is going somewhere else. Now, they say black holes allegedly suck up even light, even though light doesn't have any mass. And that's the explanation for why black holes are black. It's a very mathematical way of explaining something. A mathematical way of explaining a material, which is interesting. Mathematicians and physicists come up with weird ways to put materials into equations. They come up with quantum numbers, they come up with spin, and all these sorts of ways of describing matter, whether or not those are good ways or not. They also come up with very exotic particles and descriptions of how the universe works, but I think we should look at fundamental materials instead to see the building blocks of the universe. Chemists teach us that everything in the universe is on the periodic table, and I've been unable to find some of the exotic substances such as what neutron stars are made of or anything like this on the periodic table. So how would anyone from a materials perspective approach the building of a black hole? So I think the colour of a black hole is carbon. I did a quick Google search for black elements. In fact, there are really just two, carbon and boron. Everything else is colourless or silver, sometimes yellow. That's fine with me because carbon is exceptionally abundant and it's perfect to give the black colour to a black hole. How? I did a search for the blackest substance and came up with something called Vantablack. Vantablack is one of the darkest substances known, developed by UK company Nanosystems. It absorbs 99.965% of incident light. Here is a piece of Vantablack which has actually been grown on metal foil. In fact, metal, which is usually a catalyst for anything in chemistry, seems to have a clear role in the creation of Vantablack. And that's actually a clue to the composition of black holes as well. What is Vantablack made of? Carbon nanotubes. It seems these tubes capture light in a high surface area and won't release it as visible light or anything it seems. I assumed it would be a complex process to synthesize this stuff. Au contraire, it is not very hard at all. One of the easiest complex techniques is electrical arcing between anode and cathode. Much of the black resulting substance is in fact carbon nanotubes. So it seems they form quite easily and spontaneously, especially in the presence of certain metal catalysts, which are required for their formation. And that's fine by me, because I think most of the mass of the black hole is metal. It's probably a large ball of copper or silver, being highly conductive, as well as iron and heavy elements as well. I think the electric black hole is essentially a ball sparking heavily with the rest of the galaxy. Being at the centre of the galaxy, this intense sparking coats it literally in nanotube carbon. In this way, the chemical explanation actually supports the electric universe theory. There is one type of vantablack which only absorbs visible. It's called vantablack S-vis. So they actually have tested these, and it's not just visible light they're absorbing all lights. And actually, here's a funny aside. For some reason, it was exclusively licensed to an artist called Anish Kapoor for use in his sculptures. And this actually created outrage in other artists, or maybe attention-seeking artists, such as Stuart Semple, who retaliated by banning Kapoor from the use of the strongest shade of pink that he was able to develop. There you go. Anyway, back to the theory. So I did some more searching to confirm the idea that carbon nanotubes must be abundant in nature, if indeed they coat black holes. If so, they must form easily in the lab. Well, let me quote from an abstract of a 2017 article called Biological Effects of Carbon Nanotubes Generated in Forest Wildfire Ecosystems Rich in Resinous Trees on Native Plants. Carbon nanotubes, CNTs, have a broad range of applications and are generally considered human-engineered nanomaterials. However, carbon nanostructures have been found in ice cores and oil wells, suggesting that nature may provide appropriate conditions for CNT synthesis. The article goes on to talk about spontaneous carbon nanotube formation during forest fires. The article is amazing, even suggesting increased plant seed germination and growth rates in nanotube soil mixtures. This means, to the authors and to me as well, that nanotubes must have been intrinsic or related to the early development of life in hostile, non-life climates. I would personally suggest that the regularity of the nanotube structure in fact provides a lattice for the formation of early life or the generation of early forms of genetic code. This could be formed directly on the surface of a huge black hole and then somehow electrically blasted out along the spiral arms, spreading early life throughout a galaxy. Until it found a planet on which to evolve for the very first time, perhaps it might even be required to detonate a black hole, since they allegedly have intense gravity, and that's how we detect black holes. We can't see them, we don't know really how big they are. It's speculated on paper that you can simply compress matter and make them very small, but again, we can't see them. So I found a 29... Now you're going to say, Charlie, black holes block all light, don't they? Well, I found a 2019 article saying there's a new type of vantablack, so they're improving this process all the time, which reflects back 10 times less light than vantablack does. This substance absorbs 99.995% of visible light. Now that's coming pretty close to 100%. And the MIT scientists who did it are baffled as to why. Let me quote from that article. Wardle and a team of researchers at MIT created the coating while they were experimenting with ways to grow CNT, carbon nanotubes, on aluminum to improve its conductivity. When exposed to the air, aluminum forms a layer of oxide which hinders its heat and electricity conducting properties. To remove this layer, the scientists soaked the aluminum foil in chlorine-based salt water. The etched foil was transferred to an oxygen-free environment, then placed in an oven to grow CNT by chemical vapor deposition. Now, as expected, this process improved the material's thermal and electrical properties, but the colour of the material surprised the researchers. Now, this is a guy called Kahang Kui talking, and he says, I remember noticing how black it was before growing CNT on it, and then after growth it looked even darker. And he said, I thought I should measure the optical reflectance of the sample. Kui tested the material while lit from every possible angle, discovering that it absorbed 99.995% of incoming light. And the scientists say that there's a lack of understanding as to why this material is the blackest, but there's literally tiny forests of clusters of carbon nanotubes which are trapping light. I found another article proving the relation between DNA and carbon nanotubes relating to arc discharge experiments, and it seems it's from 2005. It's called Development of Arc Discharge Method in Organic Solvents for the Formation of DNA Encapsulated Carbon Nanotubes. The fact you can encapsulate them so easily with arc discharge, you can encapsulate DNA with these nanotubes so that the DNA and nanotubes actually go together in non-life substances, or things we can't really describe as life. In fact, this seems almost like a prototype of the virus, something that's encapsulated with a protein sheath, but in this case it's not built by protein, it's almost like a crystalline carbon which forms from electrical sparking. And I think that's how DNA might have been spread through the galaxy, in these nanotubes. And that's so fascinating. If I'll just quote very briefly, it says usually a carbon nano. Now I'm looking at another article, carbon-based nanofillers in their rubber nanocomposites 2019, and they actually say usually carbon nanotubes synthesized by arc discharge show a high degree of structural perfection. However, a number of variables, temperature of the chamber, the composition and concentration of the catalyst, the presence of hydrogen, influence their size and structure. And they've tried lots of different types of electrodes and other chemicals in their arc discharge experiments. And they say ferrium, which is iron, cobalt and nickel are often required for the production of single-wall nanotubes, whereas multi-wall carbon nanotubes are provided by arc discharge without any metal catalyst. So I think these carbon nanotubes have coated the black holes in very deep layers due to continuous electrical activity, electrical sparking, and the plasma focus gun, which is what the electric universe say is at the center of black holes. And again, I think they are highly conductive substances. Now, there are other types of black holes as well. They speculate they're very tiny black holes. These actually have been suggested to be orbs or UFOs by some authors in the alternate field. But I can't even talk about that because physicists are so far unwilling to even admit the existence of an orb, let alone begin to be petrified about claiming they might be a real physical phenomena. I'll leave the rest to you. What do you guys think of this theory? This is how I would build a black hole if I was building it in the lab. I would essentially build a plasma focus device out of copper and silver, and then I would coat it in carbon nanotubes with graphite by sparking with graphite electrodes. And that would be a substance that doesn't reflect any light. It's a substance that can focus plasma around it. That is a black hole. Tell me if I'm wrong. What do you think?